Welcome everyone, today we're going to be looking at place value. So we need to decide what place value is and how to use it, as well as looking at multiplying and dividing by tens or multiples of tens. So starting off with what place value actually is. So place value is the value each digit in a number is given. For example, we've got this number here, 5,427.39. And so every single digit in this number is assigned a particular value depending on its position. So for example, over here in blue, the 5 is in the thousands column, so that is worth 5,000. The 4 is in the hundreds column, so that is worth 400, and so on, all the way down. Now, after you've gone past your decimal point and you go into the tenths and the hundreds, the same pattern just repeats itself, so then you go to the thousandths, then tens of thousands, and in the same way, if you were working your way this way, you go to the tens of thousands, hundreds of thousands, millions, and tens of millions, and so on. So, write down the value of the digit 4 in the following numbers. So 342. So you've got to decide whether that's in the tens, the hundreds, the thousands, what column is that in. Now the number we have here is 342. So the way I like to decide which is in is I always start off with the ones. Now the ones is just going to be the last number before the decimal place. So you know that the 2 is in the ones or the units. The 4 is therefore in the tens. So you would say that we have 4 tens, which would be 40. If you have 4 tens, you have 40. Now the value of the digit 4 in this one, now this is the first one after the decimal point. And if you look up back at the example number here, we said that was the tenths. So you have 4 tenths, which would be 0.4. Okay. Write 7 million in figures. So earlier we talked about if you were to work your way left from this number, you get into the tens of thousands, hundreds of thousands, and eventually you get to the millions. Now I recommend knowing that a million is just, so for example 7 million is just 7 with 6 zeros afterwards. A million just means there's going to be 6 figures afterwards, and if it's just 7 million by itself, then it's just going to be 6 zeros afterwards. And using the same idea, 3.8 million, well, this is just going to be, first number will be 3, the next number will be 8. And remember the amount of figures after the first number, because it's a million here, is just going to be 6. So instead of having a 0 here, like we did before, we have an 8. And the rest is just going to match up perfectly, fill up with zeros. So you've got 0, 0, 0, 0, 0. And you can see you have 1, 2, 3, 4, 5, 6 figures after that initial number there, the 3. So 3.8 million would look like that. Write the smallest possible 3-digit number using the following number cards. Well, the smallest number would always start from left to right, from the smallest to the biggest. So if you were to put a number first, you're always going to choose the smallest number if you want to minimize the overall number itself. So the smallest number is going to start with a 2, and then the next smallest number would be a 3, and the last would be a 5. That would be the smallest possible 3-digit number you can make from those 3 number cards. If it was the other way around and it asked for the biggest, then you'd start with the 5, then the 3, then the 2. So write the following numbers from smallest to largest. So what we're going to do here, we're just going to compare the first 2 because they look quite close to me, and then we're going to compare the second 2 afterwards. The reason why we can sort of split that down the middle in this case is because 5.2 and 5.23 are quite clearly larger than 5.04 and 5.02, because you can see in their second figure here, so in the tenths column, they've got zeros, whereas these first 2 have 2s. So because they've got a 2, which is bigger than 0, these first 2 are quite clearly going to be larger than the second 2. So let's just focus on breaking it down into 2 smaller problems and decide which is the bigger out of those 2 pairs. So 5.2 and 5.23, and again 5.23, this number here, is definitely going to be larger than 5.2 because it's got that 3 afterwards. The way you can think about 5.2 itself is all the numbers after this are just zeros, whereas 5.23, the 3 is quite clearly larger than the 0 we had. And so we know for a fact that 5.23 is going to be the largest number because it's bigger than 5.2. Now, looking at 5.04 and 5.02, using a very similar idea, you can see how the second number after the decimal place, so in the hundredths column, Well, the 4 is quite clearly larger than the 2. So 5.04 is going to be bigger than 5.02. So the smallest number out of all these is going to be 5.02, then 5.04, and then we said that the smaller of the two out of 5.2 and 5.23 was 5.2, and then 5.23. So this here would be the order from smallest to largest. Next up, we need to look at multiplying and dividing by 10, and then multiples of 10 in a minute. So if you multiply a number by 10, it shifts the decimal point 1 to the right, and division would move it to the left. So for example, looking at 2.58, if you were to times this by 10, it just has the effect of taking that decimal point and moving it one place to the right. So you would have 25.8. And division does the complete opposite. So looking at 359 divided by 10, well, remember the decimal point for 359 would be just after the last number there. And if you're dividing by 10, it's going to move it to the left by 1. So you'd end up with 35.9. So let's look at a few examples of those. Find the value of 23.708 times 100. So timesing by 10 moves the decimal point once. Timesing by 100, since it's got 2 zeros here instead of just the 1, is going to move the decimal point twice. In the same way, timesing by 1,000, because it's got 3 zeros, to move it across 3 times, and so on. So 23.708 times 100 is just going to move the decimal point 2 places to the right. So you just get 2370.8. And divided by 100, exactly the same, but just the other way. So the decimal point was here, it's just going to move 2 steps to the left. So you get 7.65. 35.2 times 1,000 is going to jump 3 places to the right. So let's write this out again just to give ourselves a bit more room. So 35.2 is going to move 1, 2, 3 places to the right. So that's where our decimal is. And what we need to do in each of these jumps and each of these gaps here is just fill them with zeros. And so our decimal point is no longer here, it's all the way at the end there. So you get 35,200. And there's no need to actually include your decimal point here, since that's just a whole number. 13,000 divided by 10,000, in exactly the same way, you'd have the decimal at the end here, and we're dividing by 1,000, so we need to jump 1, 2, 3 places to the left. So you just get 13 in that case there. So given that 18.3 times 110 is 2013, find 1.83 times 110. So if 18.3 times 110 is 2013, 1.83, you can see we've just divided the 18.3 by 10. So we're starting with something that's 10 times smaller. And we've kept the second part, the 110, is still the same. So that's just going to have the effect of making the overall result, so 2013, 10 times smaller. So we need to divide it by 10 essentially, and that would just give you 201.3. Part B, 18.3 times 1,100. So again, what we've done is we've times the second number by 10, and that's just going to do the exact same thing. It's going to times the overall result by 10. So you're going to have 20,130. It's just going to add a 0 on the end of the result there, because we've times the second number by 10. 1.83 times 11. Now both of these numbers, 1.83 and 11, you can see are 10 times smaller than the original sum. So we've divided 18.3 by 10 and 110 by 10. So we've divided by 10 twice. Now that has the effect of making the original number, 2013, 100 times smaller. It's basically going to take 2013 and move the decimal 2 places to the left. So we're going to get 20.13, and that would be your final answer. Lastly, given that 2088 divided by 87 is 24, find 2088 divided by 870. So you have to be a bit more careful when it comes to division, a bit more careful thinking for these ones. So we are dividing by something that is 10 times bigger. So that's actually going to make our overall result smaller by 10 times. Remember, if you're dividing by a bigger number, it's going to make your overall result smaller. So you're actually going to have, instead of 24, you can have that be 10 times smaller, which would be 2.4. Next up, 208.8 divided by 87. So what's changed here is this first number is 10 times smaller, so the number we're starting with is 10 times smaller. And again, what all that's going to do is make the overall result 10 times smaller, since the 87 is still the same. So you're going to just have 2.4. The overall result is 10 times smaller. Now lastly, you can see both the 2088 was divided by 10 and the 87 was divided by 10. So we're starting with something that's 10 times smaller in 208.8, but we're also dividing by something that's 10 times smaller. So those two effects are going to cancel each other out. And so the overall result is not going to change. It's just going to stay as 24. And that's everything we wanted to look at today. So hopefully by going through all those examples, we managed to clear up what place value is and how to use it, as well as multiplying and dividing by tens and multiples of tens. Thanks a lot for watching. Thanks again for watching. For more great resources to help build your confidence and ace your exams, feel free to head over to www.katala.co.uk, where you can sign up for free today. If you enjoyed the video, please like and subscribe, and if you have any questions or suggestions, just comment down below. Thank you.